let's see what this geometry looks like in 3D. So here I have three vectors in three-dimensional space. Now in this particular example, these three vectors are linearly dependent. You can kind of see it if you look at it edge on. Do you see how all the vectors kind of line up like that? That means they all live in the same plane. This is the span of the vectors, but you only need two vectors to describe a plane, which means I could take one of the vectors out and still span the same plane. Okay, that means that vector is a redundant vector, which means the vectors are linearly dependent. Okay, I can express the vector w in terms of the other two vectors. And so in a way, it depends on the other two vectors. Okay. This one's a little different. Again, I have three vectors, but notice there's no way that I can line them up so that they all three line up together. Okay. They don't all live in the same plane. If I look at the plane that the red and the blue vector pass through, notice the green vector does not pass through that plane, which means it is independent from those other two vectors. No matter how much I move along the red and the blue vectors, I have to stay inside that plane. The green vector takes me away from it. Together with the green vector, the red, blue, and green vector actually span the whole three-dimensional space. Okay? So these three vectors are linearly independent. If I take any one of them away, they wouldn't span the whole space anymore. They'd only span a plane. Last example here. This time I have four vectors. Okay. Now, no three vectors all lie in the same plane, but I do, these three vectors are in only three-dimensional space. I only need three linearly independent vectors to be able to span the entire three-dimensional space. A fourth vector is not necessary. I can get to the fourth vector using any of the other three. And so these vectors are going to be linearly independent. So generally, you need one vector to span a line. You need two linearly independent vectors to span a plane. You need three linearly independent vectors to span three-dimensional space. In this case, I have four vectors, which is more than I need to span three-dimensional space, so they must be linearly independent.